Hey friends, here we are in chapter 4, section 4. We're going to talk about transformation with matrices here in Algebra 2. Our vocabulary, we got a lot of stuff to talk about. So let's go ahead and make some space if you're taking notes and let's see what we got. So the first one is vertex matrix. So first we have to start off with a picture, some kind of a shape with vertices on our coordinate plane. And so now we've got this triangle. What we're going to do is show the vertex matrix for this triangle. All right, so there it is. We take each of the vertices of the particular polygon that we're dealing with. In this case, it's a triangle, and we got negative 3, 0, 1, negative 3, 2, 1, just like we do for each point. Notice x, y is the order that we're writing in. So if I have a situation like this, I can do things called transformations. Like I could start off with this image of this triangle. In fact, this image I'm going to refer to as it's kind of like my pre-image. All right. So this is like the pre-image, the original, the image before I make all the changes, the original image. And so a transformation would be to take a pre-image and do stuff with it. In a sense, distort it. One type of transformation is just to move it around, right? Or just and that has a specific name that's called a translation. And we'll talk about these. So a transformation is to change it. You know, just like anything, to transform something is to change it, right? And specifically, we could change the location, the size, and the orientation of an image or of a pre-image. So if this is our pre-image, the image, this could be the image, right? So the image starts off, and it's kind of a little shady. I had to do some finagling to kind of get it to be a different color. But anyway, so the image is the original. The pre-image is the original. The image is the thing that I create by my transformation. And so one transformation is simply moving locations. Another one is to change sizes. You can make it bigger and smaller. And another type of transformation we have is a rotation where you kind of change the orientation of it, okay? And so we'll talk about those. And so the image, we know what the image is. I'm going to check that off. So it's the transformed pre-image. Isometry is interesting. Anytime you have a transformation that keeps the size of your image the same, then that transformation is an isometry. So this transformation where the size of the pre-image and image are the same is called an isometry. One type of isometry is a translation. And so a translation is a transformation, one of these kind of changes, where the image is just a relocation of not the presage, but the pre-image. Let's see, it doesn't like the word pre-image, so I'll write it again. All right, and so that's what we have here. Now we talk about this idea of a dilation and a reflection and a rotation, and you guys know exactly what this is. We kind of talked about it. So a dilation is when we have a picture that's changed in terms of its size, right? So if I start off with, let's say, the pre-image of this quadrilateral, and then I were to create, let me copy that. So if I copy it, here's the other one, and I were to create this other guy, and let's make it blue, and I were to stretch it out, this is a dilation. So any kind of stretching or compression would be considered a dilation. So all of these are considered a dilation of one another. I'm going to change this to red, and I'm going to make it small. And so this is a type of dilation. If the green is the pre-image, these guys could be the image depending on what kind of dilation we make. A reflection, this one's a little bit harder for me to use the tools of my drawing board to do, or the tools of this app. But what I can do is talk about, if I had a triangle that looked like this, its reflection on the other side of this would be like that, something like that. Let me try to erase some of this bad stuff here. And so we would have, these guys are reflections of one another, where this side and this side are the same length, this side and this side are the same length, and these two sides here are the same length. And so they're reflected. In this case, I would look at this as being reflected over like the y-axis, if this were on the coordinate plane. And finally, a rotation, which we saw before. If we take our last picture that we were dealing with, we could take this guy, let me change it to black, and we can rotate it around a particular axis or by a particular amount of degree. So those are the things that we're going to talk about today. Let us get started. So here we are, example 1, find the coordinates of the vertices of the image of quadrilateral QUAD with Q being at 2, 3, U being at 5, 2, A being at 4, -2, and D being at 1, -1. If it is moved 4 units to the left and 2 units up, then graph QUAD and its image Q prime, U prime, A prime, D prime. All right, so we've got a lot of work to do. First, let's start off by coming up with the vertices, the vertex matrix. So here's our vertex matrix of QUAD, and now we're going to come up with our, I'm going to call it a translation matrix. If we're moving if we're moving this particular image 2 units to the left and then 2 units up, when you move things to the left on the coordinate plane, you're moving it this way in a negative direction. So if you're moving it, let me see if I got this right. If it is moved 4 units to the left, so the X movement would be 4 units to the left. So here's my translation matrix. Each of these has to be moved 4 units to the left and then 2 units up. Our Y values have to increase by 2. And so now we're going to add these two matrices together and we get the image, which is going to be -2, -3, no, just kidding about the -3, chablitos, -2, 4 plus -1, no, +1, I can add, I promise, 0, and 4 plus -3. And then the next row is going to be 5, 4, 0, and 1. And so thinking of these as my pre-image and my image, I'm going to graph them on the coordinate plane below. And there's our pre-image and image right there on the same coordinate plane. All right. In this short response test item, we are given A prime, B prime, and C prime as a result of a translation. So we know it's just a movement of the original image or the pre-image ABC. And we are to determine or to use this table of values to figure out what A and D prime are. What would be helpful at this point is to kind of figure out what is the change that happened, what's going on. And so when I look at the X coordinates of this, of B and B prime, I see that there's a movement of 3. Look at the X coordinates of C and C prime, again, a movement of 3. So that looks like if I were to make the translation matrix, right, 4 points, so I got to have 4 things. The change that's happening with the X is going to be +3. Do you guys see that? So I'd have a bunch of +3s going on all over here. And then for the Y, if I'm taking a look at the Y, I'm going to see that I go from 5 to 1 and -2 to -6, which looks like movement or a drop of 4. So I would have -4 here. And then so I now can use that information to figure out what's going on here for D really easily. Add 3 and I get a -1, and then subtract 4 and I get a -6, which feels right. Here, I need to figure out where did I come from such that when I added 3, I got -1. And so if you add 3 to something and you get -1, that means that that's like taking -1 and subtracting 3, which you get -4. Think about it. -4 plus 3 is -1. Let's do the same thing here. If I add -4 to something, or if I take 4 away from something, I get 1. What must that be? It's the same as taking 1 minus a -4 or having 5, because 5 plus -4 is 1. And this is what we get. Those are the two values. And this would be the translation matrix. Example 3, dilation. Triangle JKL has vertices J being -2, -3, K being -5, 4, and L being 3, 2. We're going to dilate JKL so that its perimeter is 1/2 the original perimeter. What are the coordinates of J prime, K prime, L prime? And so we'll start off like we did last time, looking at the vertex matrix. And what we have to consider when we're dealing with a dilation, right? When we're dilating something, what we need to consider is what is the scalar, the number on the outside that we're going to multiply our whole matrix by in order to get the desired resultant image, which of J prime, K prime, L prime, which we know is to be 1/2 the original perimeter. So in order to get that, what we're going to literally do is multiply the original by 1/2. And when I do that, I'm going to multiply by the scalar 1/2, which means to multiply each thing inside of the parentheses, or inside of the matrix rather, by 1/2. And so I end up with the following matrix here. And so now we're just going to graph it and check out how the original relates to the image. And graph below here, we have the resultant pre-image and image. This is something that you want to copy down. If you want to reflect an image, now we just did translation, we did translations, we did dilations. Now we're going to talk about reflections. If you want to reflect an image across the x-axis, you're going to multiply it by this matrix. Across the y-axis, you'll do this matrix, and across the y equals x line, you'll use this matrix. So here we see a reflection over the x-axis. Here I'm attempting to show you a reflection over the y-axis in this green and blue. And finally, a reflection over the y equals x line would look something like this. And we can determine those coordinates by using these matrices. Let's try an example. This problem is asking us to take QRSTU and make it a reflection over the y-axis. So I've written the matrix that refers to the vertices, and now for a reflection across the y-axis, this is the matrix that I need to use, and so I'm going to multiply the two. Realizing I can't do it this way, I'm going to take this whole thing and I'm going to move it over here, and I'm going to multiply it like this. Now that we have it oriented correctly, now we're going to go ahead and see what happens. We're going to multiply through. So after multiplying through, we get this matrix, and now we need to graph Q prime, R prime, ST, U prime. And I color coded them so that you can see which one is which. So in addition to using matrix multiplication to find reflections, as we saw before, we can also do them to rotate our matrices. So this is something else that you want to hold on to rotate a matrix 90 degrees, 180 degrees, and 270. These are the matrices that we will use. So in example 5, we're going to rotate triangle ABC, whose vertices I put in the matrix. We want to rotate it 90 degrees. That type of rotation requires a multiplication by the matrix 0, -1, 1, 0, as per our information that we got up here, right? And so now we're going to just multiply through like we know how to do, multiplying across, and then down. After multiplying, here's the resultant matrix, and that's going to be our matrix A prime, B prime, C prime. And now we're going to graph that. And here is this image, this original pre-image, and then it's rotated this way. When we think about that rotation, we're thinking about it about the origin. So if I were to start at the origin and take this vertex and bring it over here, it's kind of like a 90-degree angle. Am I making that up? No, I don't think so. If I were to take this vertex here and bring it over here, it's like a 90-degree angle. If I were to take this vertex here and bring it over here, you see that? Like, no, don't want my sound effects, but you kind of get it, right? Okay. All right. So that's how we do it. That's how it's working. Let me know if you have any questions, concerns, or comments, and I will talk to you soon. Take care.